because we're going to have to apply the thought behind it to rational functions or rational expressions, which is a cluster of x's all over the place. So we're going to just see how it goes. So I don't need you to reduce this for me, this 18 divided by 27. What I need you to do is I need you to think, how do you reduce it? What would be the step for you to actually reduce that fraction?
Finding the greatest
Yeah, you're finding the greatest common factor. Another way of thinking about that is you're kind of like listing out the numbers. The greatest common factor in this case is 9. So I would have 9 times 2. It's another way of writing it. And this would be 9 times 3. Now, we actually did this in chapter 11 partially because we were building towards this. So when you were taking square roots and you were writing the product of primes, we were thinking about this. Because now the 9's cancel out. And we're going to see how that plays out as time goes on. So if you want to write stuff down here, you can. You don't actually have to. Like, I'm not worried about this page until we get to the very bottom. And I'll tell you then when we get there. Fractions, how do you multiply a fraction? Straight across. Now, when you multiply fractions straight across, you still need to reduce first. So I don't want to deal with big numbers. So I'm going to write 3 and 5. And then for the 18, this time I'm just going to write it as the primes. And again, you don't have to worry about writing all this down. It would just be 3 times 5. And then 18 is 2 times 3 times 3. So I look at the top of my fraction and the bottom of my fraction and go, okay, what is the same? What can I cancel out? So I have 2 3's on both the top and the bottom. So I cross those off. And then I have 5, so I cross those off as well. And I'm left with just 1/2. Sometimes I joke about this being like the butcher unit because you're just slashing things off. Just whoosh, gone. All the time. That's all we do. Okay? When you are dividing fractions, what do? Do what? That we're getting to that, but it's not going to be yet. When you're dividing fractions, what do?
Flip the last.
Keep, change, flip. So I'm not going to actually go through all of this. I'll write 3/5, and then I'm just going to go times 18 over 15. And we would do the same exact process. We would write out the numbers that are there. We would cross off the like numbers on the top and the bottom, and then just multiply whatever's left over. So I'm not going to do that. Okay. Addition, we're going to ignore this one. How would I get a common denominator for that? What would my common denominator be? Say it, Keegan. What'd you say?
I said 10.
10? All right. Can't be 10. 10's part of it, but no.
5 can go into 10. 10 can go into.
We're looking at common denominators, though, so 10 and 12.
Wait, which one are we looking at?
The next
I
one.
was looking at the wrong one.
All right. 10 would have been right for that.
Oh, okay. I was looking at that one.
Okay, so then looking at the other one, what are we thinking? All right. 120. Okay, how do we get that 120? You're really just going 10 times 12, so you're taking the denominators and you're multiplying them together. So I get 120 as my denominator here, and then I'm actually going to pause and not do anything else. Because when we actually add these rational expressions together, I will work through that more. But this is the first step. This is the key. Once we get this, it unlocks everything else. Okay? So I do apologize. This is not the most exciting unit out there. Okay? This is a foundational unit for higher level math. So for those of you taking L3 next year, if you take pre-calc or things like that, this is like a building block to make sure that everything you do is fine. Now, they use these whenever we look at medicine or other stuff like that, but I'll be honest, the main reason that we're looking at this now is a building block, so when you go to higher math, you can do more things. Last thing that we look at on the front page, this one I need you to write down, okay? So what is the only number that we can't divide by? 0. When we divide by 0, bad things happen, okay? And so we put restrictions on our rational expressions. We restrict our denominator. We restrict only the bottom piece of the fraction. So I'll tell you right now, if I'm asking you what your restrictions are, none of this matters. And you don't have to cross this off. All of that is irrelevant. It means nothing, okay? So my restriction for the very first thing is x cannot equal 0. Because if x is 0, I would be dividing by 0. Can't do that. When I look at the next one, My restriction is x cannot equal what? What makes that 0? 2. So I put a 2 there. I'm going to jump now. We're skipping that middle one. We're jumping to the next one. What can x not be? 0. Can it be -1? Yeah, it can be -1. Because I don't care about my numerator, right? I only care about the denominator. So this can be -1, it can be 30, it can be 50, it can be an infinite number of numbers. The bottom just cannot be 0. That's it, okay? Now we actually don't do a whole lot more with this today. We just kind of throw it out there because we let you digest it. And then tomorrow, we bring it back, okay? And we make it a little more complex. So go ahead, flip that page. You're going to be getting stuff like this. So there's 3 parts to our chapter. The first part is, can we simplify and do basic operations? Can we add, multiply, subtract, divide? No solving, nothing. The next 2 days are solving. Can I solve if it's cross multiplying? Can I solve if I have this big ugly fraction? How do I deal with it? So we're just building, honestly, for those next 2 days right now. And this is how it starts. 27, 27. Nothing's happening to it. Going to draw a fraction bar and put 27. This is where you put your 2 favorite F words in math together. Fractions and factor. Now we go 63x plus 45. What is 63 and 45 divisible by? 9. And 9's perfect. You also could have told me 3, but you want your greatest common factor. So if you would do 3, we'd have to do more steps. I'm never going to let you in class choose a number that's not your greatest common factor. I'm going to make you choose the greatest common factor, okay? But if you don't choose it, you could still get the right answer if you continue on. So I put a 9 right there. I get what? What's inside here? Yes, and I need just a little bit more. 7x. Yep. Okay, so we got that. And this is why I say you're just slashing away here. 27 divided by 9, what's that? 3. Cross that off. I got 3 divided by 7x plus 5. That's your answer. Look how lovely that looks. Amazing. Okay, when you're, how many of you have a younger sibling? How many of you show up possibly after, like, your family ate dinner, and it's like, I know what we ate for dinner, because it's all over their t-shirt? None of you? Wow, good for you. Your families are better than mine, I guess. We're looking for breadcrumbs in all of these problems. I'm going to tell you that over and over again. If you're looking at factoring and you're like, I don't know how to factor this, the problem is actually giving you a hint. And you'll see what I mean by that in a moment. Because we're going to gloss over it for the first problem, and then after this first problem, we're always going to look for breadcrumbs. So I have n plus 8 on the top. I have this lovely trinomial on the bottom. And so now we start thinking about it. N squared plus 5n minus 24. The first item of a polynomial of, in this case, the trinomial, gives me the first piece of both parentheses. So n squared gives me n times n, okay? Now we look at the 24. What numbers multiply to 24? That's going to give me my numbers on the back end of the parenthesis. List them all up. 8 and 3, what else? That is the correct numbers you use, but we're still going to list them all up. 8 and 3, what? 6 and 4. Good. So we have our list of numbers. You have to run through your numbers. Now, Keegan got the correct numbers right off the bat, the 8 and the 3, and it works because of this. We have a minus sign right there, which means I'm going to have a plus and a minus sign. So to get a negative number, you need to multiply one of each sign. So I'm going to put a plus and a minus. I have a positive 5. So if I'm using 8 and 3, I can get 5 from that. But if it's positive, which number has to be positive, the 8 or the 3? The 8, because when I go 8 minus 3, it gives me positive. Or it gives me, the positive 5. So I got that. Now, I see there's breadcrumbs in here, because otherwise if you did this over and over again and nothing got slashed out, that'd be really boring. Really, really boring. What cancels out here? N plus 8. So this is gone. We did all that work so we could do that. That's nice. So now I got 1 over n minus 3. This is where I'm telling you there's breadcrumbs in the problem. If n plus 8 is there, 8 times what is 24? 3. Well, that's probably telling me maybe I want to try using n plus 8 down here and try to factor that out because I'm looking to see if things cancel. Does that make sense? We're looking for patterns. We're looking for things that are going to help you. Not just the math, what is going to make this easier. We go to the next one. Fraction bar. Start factoring what is the easiest to factor. What's easier to factor, the top or the bottom? Bottom. All right, what's my greatest common factor for the bottom? 4. So I'm going to have 4 and then x plus 10. Okay. Let's explore the breadcrumbs here for a minute. If I look at x plus 10 and I look up here, I have a trinomial. I know I'm just going to have x and x. Now I look at my breadcrumb. Well, 10's right there. 10 times what is 10? 1 and 10, 2 and 5. Oh, look at that. I have an x plus 10. Let's just try that out. So I'm going to put plus 10 right there. Okay. Now looking at this, x plus 10. 10 plus what is 11? 1. 10 times 1 is 10. So that kind of checks out. So I'm going to put a plus 1. Now we have 2 plus signs, so that means we're going to have 2 plus signs in there. I'm not encouraging you not to factor. I'm encouraging you to just look for the shortest way possible to get through the problem. The easiest way possible to get through that problem. If something is sitting there, let it help you out. This does factor correctly. What cancels? What's our solution? Good. Questions? Next problem we're going to do. You got to realize that what we just did, the simplifying, is basically the same as multiplying. Right? I can just get rid of that dot right now, put parentheses here, and now it's just simplifying that. We're not going to do this one. We're going to go to the next one. So when you're multiplying, you just draw that fraction bar and you have just a bunch of stuff there. Let's take a look at all this stuff. So we're looking at this. What's the easiest thing to deal with? Which piece? Your choice. All of them look fine to me. Which one? Griff, it's all on you. What do you want to start with? I'll even do the work.
I'm taking top.
The top. All right. 21x minus 7. What multiplies into 21 and 7? 7, which gives us 3. So I'm going to put 7 right here, and then I'm going to have 3x minus 1. I like to break up where my pieces are by putting the time sign in there, but you don't actually have to. Okay, that's just a preference I have, but it's not something that's needed. 6x plus 8. What's it break down to? What's the GCF? 2. So then we get 2, and then I get 3x plus 4. Then I'm going to continue going down. So 7x plus 70. GCF is 7. So I get x plus 10. Then I have this lovely item right here. 9x squared plus 9x minus 4. By itself, that one looks a little daunting, and I'll show you why. So it looks a little daunting because I don't just have x squared. I can't just put x and x in. I have to choose to either do 9x and 1x or 3x and 3x, which means right there's possibilities that are happening. When I look at 4, that means I'm going to be looking at 1 and 4, or I'm going to be looking at 2 and 2. So possibilities, lots of different options. But guess what? The answer's already screaming at you in the face. Yeah, we're going to use 3x. And I'm going to use 3x because I want to be lazy. I want to see is something going to cancel out here. Well, I have two 3x's actually. And I have a 1 and a 4, and I have a 1 and a 4, and I have 3x and 3x. So let's try it out. Let's see if it works. 3x minus 1, 3x plus 4. Off to the side here is where I'm going to do this. I multiply the first two pieces together, and I get 9x squared. So I'm just distributing out. Go to the next one, 12x minus 3x minus 4. Check, check. Combine those together, 9x. Check. You can almost do that entire problem without factoring this. So, it's all about the choices you make. They can help you speed things up, or they could maybe make things a little bit more difficult. But you can absolutely still do the problem. What's canceling out? Yep, so we got these two things gone. What else? Anything else? 7's cancel. So I'm left with 2 divided by x plus 10. Questions? We did the hard one for the multiplying, so we're going to do the easy one for the division. And remember, when you're doing division, you just flip the fraction on the backside. So how I like to do this, I'm going to just copy this all down. So I got x squared plus 4x plus 3. Since I'm writing this as one fraction, I want to put parentheses around it. And then I got 4 right there, because again, this gets flipped. And on the bottom here, I got 2 times x plus 3. Overuse the parentheses, okay? You won't have enough when you do these problems, so use a lot of them. Some of you are going to ask me, hey, Nichols, I don't want to write x plus 4x, or x squared plus 4x plus 3 down twice. Can I just factor it right away? Yeah, you can. I'm good with that. You got to factor it, though. You got to show it. So that's our next step. What does x squared plus 4x plus 3 factor to? Well, multiplies to 3 but adds up to 4. 3 times 1. So I got x and x plus 1 plus 3. What cancels out? The x plus 3 is gone. You would. So I would just take 4 divided by 2, and I would get 2. So then I actually cancel out the 4, and then I write it 2. So then we got to take what's left. I got x plus 1, and I got a 2. Now, some people are like, hey, I should distribute that. And I ask why. Why would you do extra work? Is there any context to this problem? No, it says simplify. Factored form, standard form. Both of them can be simplified. All right? I don't care. I'm just going to write 2x plus 1. Done. You can absolutely write 2x plus 2. That's fine. That's right. Just a little more work. Questions? We're not going to do the last one over here. We're going to look at these two problems. So you can kind of cut that bottom page in half so you got more space to work. It's not too crazy here. I'm going to bring back those fractions from the very beginning. So they had a denominator of 10 plus a denominator of 12. And what did we say our common denominator was? 120, because we multiply those together. So the very first thing that you do is you get a common denominator. My common denominator is this times that, which is x minus 5 times x plus 6. I don't actually like to distribute this at all, because if I'm going to cancel anything later on in the problem, it's got to be in factored form. So don't do anything else with the denominator now. Leave it. Just wave at it from a distance and don't do anything. Now we have to deal with the top pieces. So I kind of like to play a little game of what's missing. My denominator right here is x minus 5, but it's supposed to be this. What's it missing? Yeah, x plus 6. So if I want to make my denominators the same, I just have to actually multiply those together. It's what we did right here. But what I do to the bottom, I have to do to the top. And so I'll put parentheses on all of that, and I'll just write it down right here. X plus 6 times x minus 4. And then I carry whatever sign is there. So this is a plus sign, if it's a minus sign, whatever it is, I then drop that sign down. So I'm putting it in purple instead of blue so it sticks out a little bit. Then I'm going to another color. So now I look at this next piece. My denominator is x minus 5, x plus 6. I have an x plus 6. What am I missing? X minus 5. So I times the top and the bottom by x minus 5. So I now have my denominator. And I go 3 times x minus 5. You have to do a little bit of work here. You have to distribute this out, distribute that out. We combine all of the like terms on the top, and then you look, can I factor this? Because if I can factor it, then I might be able to cancel something out. If I can't factor it, then we're done. So go ahead, distribute this out. You don't need me to do that. You can do that. So distribute this out. I'll put my answer up in a minute, and then we will combine all of our terms together. When you combine your like terms, if you take a look up here first, are we good on these terms? I didn't show all of the distributing. You would have got a 6x and then a minus 4x. That combines down to the 2x. So that's where that's coming from. When we take a look at this though, I only have 1x squared. So I put that down. I have a 2x and a 3x, so I get 5x. And then it looks like I got a minus 39. So you got to ask yourself. The nice thing is that we have an x squared. Okay, those are the easiest ones to factor. Negative 39. Give me numbers that multiply to negative 39. 1 and 39.
3.
3 and? No. 13. Yeah, good. Those are actually the only options. 3 and 13. Can I get 5? 1 and 39? No. So this right here, folks, is going to be your answer. Now, instead of making you do another problem, we're going to just talk about one thing. we do this same exact process for subtracting, but instead of having, and don't change this on yours, instead of having that plus sign there, I just have a minus. So then that changes the problem just a little bit. This just makes this a minus 3x and then a plus 15. It just gets distributed throughout. Okay, so there's nothing actually else going on. And I'm telling you that because I told you already, this just takes time. It takes practice. It takes a little bit of struggle for you to work through, and it will be done, but you just have to take some time. So I'm going to give you the rest of the class to work, to ask questions.